The two topics for lesson 5-6, we're looking at the geometry of parallel and perpendicular lines. They want us to write an equation of a line that passes through a given point parallel to a given line and perpendicular. So we're going to break that up into two separate lessons. The first one, we're just going to look at parallel. How can you determine whether two lines are parallel? The graphing calculator screen, which looks really primitive compared to what we can do on GeoGebra, shows a family of linear graphs whose slope is 1. Notice that the lines do not appear to intersect. Lines in the same plane that do not intersect are called parallel lines. Parallel lines have the same slope. Two non-vertical lines are parallel if they have the same slope. Vertical lines, their slope is undefined, so they talk about them separately and say that all vertical lines are parallel. Example 1, they ask us to write the slope-intercept form for the equation of the line that passes through the point 4, -2 and is parallel to the graph of the line y equals 1/2 x minus 7. From our point-slope form, we see this line they gave us was in point-slope form, so we can see that m must be 1/2. And they gave us a point, so now we can plug into the formula. Y minus the y part of our point is -2, so minus -2 is going to be plus 2, equals the slope we found, and the other equation was 1/2, and then we have x minus the x part of our point, so x minus 4. So they gave us some extra information in the equation. We don't care what the y-intercept of that line is. It really doesn't matter to us. And then they want our equation to be in slope-intercept form when we're done. So we need to distribute the 1/2. So we have y plus 2 equals 1/2 x. 1/2 times -4 would be minus 2. And then to undo plus 2, we're going to subtract 2 from both sides of the equation. So our slope-intercept form is y equals 1/2 x minus 4. Now, since we have GeoGebra and it's easy for us to check on the graph, I'm going to throw that up here real quick. If we type both equations in the input bar and the point for -2, I can see that the lines are parallel and that my new line goes through the point for -2. That is all we're doing in this lesson, so we're going to do another one just like it. Write the slope-intercept form of an equation for the line that passes through the point 2, 3 and is parallel to the graph of 1/2 x minus 1. So they gave us a slope of 1/2 and our point 2, 3 gives us an x value and a y value. So I'm going to plug into our point slope form. So we have y minus the y part of our point, which is 3, equals the slope that we got from our other line, 1/2 times x minus the x part of our point is 2. So to get to slope-intercept form, all we need to do is distribute our 1/2. So I have y minus 3 equals 1/2 x minus 1/2 times 2 is 1. And finally add 3 to both sides. And I have y equals 1/2 x plus 2. You could graph by hand, but GeoGebra is pretty slick. And we can see that y equals 1/2 x plus 2 is parallel to y equals 1/2 x minus 1, and it passes through the point 2, 3. And here we have half of our summary statement, since we only did half of the lesson. Two non-vertical lines are parallel if they have the same slope.